In this video, we're going to discuss hybridization. And again, every chemistry class, Gen Chem especially, covers this at a different depth. This is about the level of depth that I cover in my general chem class. However, if you're watching this as an organic student, you're probably going to be expected to go in a deeper level. So, hybridization is the combination of orbitals in the same atom, and the goal here is to reduce energy. So we have sp, sp2, and sp3. Now I want to make a point here of distinguishing how hybridization is different from bond formation. So in hybridization, you have orbitals in the same atom, that's the key word here, versus combining orbitals in different atoms. If you're combining orbitals in a different atom, you're going to get a bond. Whereas if you're combining orbitals in the same atom, that's what's referred to as hybridization. Okay, so make sure you understand the difference between hybridization and bond formation. They're two entirely different things. All right, so let's look at sp first. So this is the combination of an S and a P. It gives us a linear geometry, and it's a 180-degree angle. So if you think back to your things that you learned when you were doing shapes of molecules, right? That's the linear shape. That's the 180-degree angle. You probably memorized this when we were learning about Vesper theory, or at least you should have, when we did Vesper theory. So Vesper theory comes back when we do hybridization. So if we combine an S and a P, we get the sp hybridization. All right, so you're going to get two options. If you have S in the middle, and then positive on the left and negative on the right, or negative on the left and positive on the right, you're going to get, now my drawings here are kind of sad, you're going to get two sp hybrids, right? But this is going to be a 180-degree angle. You're going to have the big lobe and the little one, and then the little one and the big one. So that is sp. And if I were you, I would just make myself a little chart, and I would say hybridization, and then I would say name, who's being combined, geometry, and then bond angles. So just summarize this. All right, make yourself a chart. sp is an S plus a P. It's a linear geometry, and it's at a 180-degree angle. Now let's look at sp2. sp2 hybridization is the combination of an S and two P's, hence the name. And again, think back to your Vesper theory. This has a trigonal geometry, and it's a 120-degree angle. So if we have S, and then this is one P, and then here's the other P, right? So this one could be P, Y, and this could be P, X. You're going to get three of these, right? And so you got one big and one little, one big and one little, one big and one little. So this one would be like the X. This one would be the, this would be the Y, the X, and the Z, so to say. And so when you lay them all on top of each other, this is what it would look like, and that's where you get that 120-degree angle. Again, this is looking at it straight from the top. So if I were you, I'd make myself a chart. You know, you've got your, so you can compare straight down the line, SP in one column, SP2 in the next column, SP3 in the next column. How does SP2 differ from SP? So if we're making ourselves a chart, you can have these two side by side. So you, when you're studying for your test, you've got your SP2 and you've got your SP, and you can quickly just memorize that and remember how they differ. And then the last one is SP3. Okay, so this is S plus 3 P's, hence the name. It has the tetrahedral geometry, and it's a 109.5-degree angle. So you've got an S plus a PX, a PY, and a PZ in essence. And you're going to get 4 sp3 hybrids. I only drew one of them. You're going to get 4, right? So this looks just like your tetrahedral molecular geometry that you learned with the bond angles of 109.5 degrees. This one, imagine coming up behind the paper, in front of the paper. This one you imagine going behind the paper, and these two in the plane of the paper. So again, if you're making yourself a chart, you have your SP, SP2, and SP3. This is the information that I would definitely expect you to commit to memory. And I hope this helps you get started with your hybridization. Again, the level of depth will depend on your particular course, but if you have questions, please feel free to contact me.